welcome our speaker for today, Ovia. Ovia is a respected research engineer at CoinDCX, specializing in proof of work blockchains with a PhD in computer science and engineering from IIT Delhi. As the Chennai chapter lead of TPG, Ovia is dedicated to fostering the growth of blockchain community. With extensive expertise and a passion for innovation, Ovia contributes to shaping the future of blockchain technology. Welcome, Ovia.
Thank you, Bhavya, for that lovely introduction.
Yeah.
I'll assume that everyone is fairly new to blockchains and new to the whole ecosystem. But yeah, you do have some understanding of what a blockchain is and things like that. So before I talk about Filecoin virtual machine, we need to understand what Filecoin is, what is its purpose, and how it came about and why it's so popular, right? So Filecoin is considered the most exciting upgrade. FVM is considered the most exciting upgrade to Filecoin since Filecoin came about. So I'm going to divide my talk into like three broad areas. First, we'll talk about what FVM is, and secondly, we'll talk about what we can build with FVM, and we'll kind of move on to a hands-on session on how you can build with FVM. Okay, so Filecoin is a blockchain network that was built on something called IPFS. IPFS is interplanetary file system. It is the world's largest completely decentralized storage network. So you must all be familiar with databases. Databases run on database servers and is controlled by the admin or whoever controls that server, right? So, but here, as problem with all centralized system, it is prone to a single point of failure, and you're completely trusting that person who owns that server. So the world is moving. Web3 is all about decentralization, and IPFS was the first completely decentralized data storage network that was built. So how that works is, let's say you want to store any file on your database, which is IPFS. So IPFS takes that file and breaks it into many small chunks, and the whole file is given something called a content ID or CID. And different people in the network, consider something like the internet, where there are millions and millions of computers all connected together. We call this a peer-to-peer network because no single person owns it and everyone has equal permissions on the network. So this file that is broken up into millions and millions of bits is given to different people on the network, and they store it in their system. And when you want to retrieve that file, you take these pieces from everybody, and then you build that file again. And all of this is accessed via that content ID. So, but what is the incentive for you to store that file in your system, right? Why would you want to help somebody else store their file? Because you're giving your resources, you're giving your memory of your system. So this is why they built an incentive layer in the form of a blockchain called Filecoin. So if you offer to give part of your storage to IPFS, you will get rewarded in FIL tokens, which is the native token of Filecoin. So Filecoin, their first step of their master plan was to build the world's completely largest decentralized storage network, which is IPFS, and provide an incentive layer on top of that in the form of Filecoin. So after that, this became so popular that after that, so many people started storing data on IPFS and Filecoin. So in fact, IPFS and Filecoin, IPFS kind of stores 18 exabyte of memory right now combined, which is a huge number. So exabyte, I had to Google this, is 2 power 60 bytes of data, which is crazy, right? So we already, Filecoin and IPFS already have, they're protecting that much amount of data, which includes large data sets. Even some of the states of other blockchain systems are stored in Filecoin. All the NFTs, collection of all NFTs is also stored on IPFS and Filecoin. So IPFS is already exists as a decentralized database. Now, what FVM does is it brings computation on top of this large data set that we already have, and this enables it enables Filecoin to build web scale applications. So this is a tweet by Juan Bennett, who is the CEO of Filecoin. So as I just said, the Filecoin project delivers on-chain programmability to the Filecoin network. So what do I mean by on-chain programmability? So if you're familiar with the Ethereum ecosystem, you must have heard of smart contracts, right? Smart contracts is a piece of code that when deployed on a decentralized network, everybody stores a copy of that program, and anybody on the network can invoke any function on that program, and it is executed and verified by all in the community, all in the network. So this functionality of writing and deploying smart contracts is now possible on Filecoin, which was not there before. And this is the feature that FVM brings to the Filecoin network. Why is this important? Because so Filecoin already has storage. It enables storage and retrieval in a very secure way, in a decentralized way. Now, if you bring compute over it, it's possible to build large web application, and the power of that is for the developer community is over $300 billion. So it's definitely something to look forward to. So let's go over what I said again. So you have the underlying layer of IPFS, which actually stores the data. Consider it as any file system on any computational device. And then you have an incentive layer on top of that, which is Filecoin. And Filecoin, this is the token of Filecoin called FIL. And on top of that, we're bringing FVM, which is the computation over the state of the blockchain, which is Filecoin. Now, once the computation is possible, you can build more powerful applications in the form of layer 2, which gives computation over this data of the chain. So let's look under the hood of FVM and see how it is built. So FVM is a system that can host multiple runtimes and serve as a seamless connection between these runtimes. So it took inspiration while building FVM. They took inspiration from 3 kind of models. First is the hypervisor and virtual machine models. We all know what a virtual machine is, right? Virtual machine is an operating system that can run on top of another operating system. The hypervisors they do the exact same things. You can have different runtimes running on top of a base runtime. Another model is the actor model, which basically signifies the interaction paradigm between the different runtimes that we've just brought in. And the Unix kernel is the inspiration from the Unix kernel is how to separate these different runtimes so that you can communicate between them. You can have different memories for each of these runtimes and have syscalls between them. And the storage is completely abstracted. So taking inspiration from these 3 things, aspects of computer science, they have built the FVM. So what are some of the features of FVM? So under the hood architecture, technical architecture, firstly, it's based on WebAssembly. So it has Wasm time running under the hood. So comparing to what we just spoke about, the 3 models, the hypervisor model, the Unix kernel, and the actor model, this Wasm time can be considered the hypervisor layer. So Wasm gives like a high level language, gives any high level language a compilation target, so that any developers can use their preferred language to work on top of EVM, right? So Wasm also imports syscalls that and declares them, which makes it easy to audit. That basically means that any wrong syscall can be identified and isolated automatically, as opposed to manual. So another advantage of FVM is it has support to build multiple runtimes, right? So till now, the Web3 ecosystem, if you take like a Venn diagram of all the apps that are there, of the all the decentralized apps that are there, dApps, you notice that the Ethereum economy is huge. They're basically running the whole show, right? So in future, there can be many different runtimes. EVM is one of them, Ethereum virtual machine, but in future there can be many. But the problem with EVM is it is based on a blockchain that has no storage. And storage and computation, right? Storage and computation programmable is a very core primitive that cannot be decoupled from any programming language or any software. So they have to go hand in hand. You write programs on that processes some data. So they shouldn't really be separated. I'm not saying Ethereum doesn't have storage. It does have storage. Smart contracts store the state of that chain and they store variables, but it is not at a scale that we are used to, right? We are used to very complex applications like, Amazon or Twitter or Instagram that has so many blobs and clobs of data like images, videos, large text files. Such storages are not possible in the Ethereum. They have to be stored on chain and then linked onto the blockchain, which makes it slightly, reduces the user experience, and it's not that flexible. So now that you can build multiple runtimes on top of EVM, you can bring all the existing runtimes also on top of Filecoin and make use of this amazing storage layer that is already built. Right? We already spoke. We mentioned the low-level system call. So now that you have different runtimes, they can all communicate with each other. And IPFS, so FVM is built on something called IPLD. IPLD is interplanetary linked data. So that is the way that the content is stored in the IPFS layer. So IPFS layer, as I said, the data is split into small chunks, and it refers, the whole file is referred by a content ID, and the actual file in order is linked to each other. So the same concept is used, is the data model of FEM. So all data is stored in IPLD format. It also supports foreign addressing support. This is important because now we spoke about a layer that has different runtime environments plugged into it. And all of these runtime environments have their own addressing format, right? So it's very difficult when you want to make your system plug and play. You cannot change the rules of the system that you're bringing in. For example, Ethereum has 160-bit addressing. Okay, so if you want to support Ethereum, you cannot ask Ethereum to change it to your addressing style, and you cannot have there is no generic addressing style existing, right? So this is useful for bringing in other runtime environments that have their own addressing with their implicit assignments. Abstract accounts. So in Ethereum, Ethereum blockchain does not have inbuilt account abstraction. So what I mean by that is, in Ethereum, if you have a wallet or an account on the Ethereum blockchain, you have a wallet address where all the asset that you own is linked to that wallet address. And that wallet any transaction out of that wallet has to be done by signing with a private key, which is basically public key, private key pair. The public key is the wallet address and the private key is what you use to sign. So the signer, which is the person holding the private key, is very tightly coupled with the wallet address, which is the address holding all the assets. So it's very difficult to separate the two. So what happens is, and any like a non-technical person who's not used to this, not used to security, it's very easy for them to lose their private key and lose access to all of their assets. In the Web2 scenario, this was okay because we have forgot password, and it's very easy to get access to your account again. But in the Web3, this is a major problem. And the only thing that can prevent this is account abstraction. That is to decouple the asset address and the signer address. So this change is very difficult to bring in now on top of Ethereum, but FVM is already has native account abstraction that makes this possible. So you can have things like you can have wallets, you can choose your own signing scheme, you can have recovery of your passwords. Even if you lose passwords, you can have somebody else generate a new one for you so that you don't lose access to your accounts. So those were some of the advantages of FVM. So I'll just quickly, FVM is of course a very hard engineering endeavor. So even now engineering FVM is still being built, like they are releasing one feature after the other. So we'll talk about the roadmap a little bit and what is already there. So in July 2022, the Skyr upgrade was installed on the Filecoin mainnet, which basically meant that as of July 2022, Filecoin was already being powered by the FVM, but it had non-programmability. That is, you could not deploy smart contracts, but it was already powered by the FVM. And as of December 2022, they installed the FEVM. So FEVM is the EVM virtual machine runtime that is plugged on top of the FVM. So FVM is a base layer that can plug in different runtime environments, and EVM compatibility was the first thing that they brought. They plugged in the EVM machine on top of Filecoin, and this is called FEVM. So why did they do this? Why did they choose to have Ethereum compatibility first? Because, as I said, the Web3 ecosystem is kind of dominated by Ethereum. They're so popular. There are so many developers and really big projects already being built on Ethereum. So it's important to get that developer base onto Filecoin first. So this is why they chose to bring in EVM first. So now whatever you can do on Ethereum, you will be able to do on Filecoin without changing anything. So Ethereum already has very battle tested and amazing tools like you have a smart contract language called Solidity that everyone is becoming familiar with. You have amazing tools like Remix, Hardhat, Truffle. You have libraries like Web3.js, Ethers.js. So since you've already learned that, if you're part of the Ethereum ecosystem, you can easily deploy on the Filecoin ecosystem. So now we'll look at what I can build on FVM. Right. So now that this programmability aspect has come on top of Filecoin, and you have the storage layer of Filecoin of IPFS, the possibilities of endless on what you can build, right? Any web application, any decentralized use case application can be built on the Filecoin network. So let's look at a few of them. So now consider the storage provider loan markets, right? So you might all be familiar with DEXs. DEX is a decentralized exchange. So think of a foreign exchange or any bank. All functionalities of a bank should be can be replicated and provided to you in the form of a DEX. DEX is a software that is running basically a set of smart contracts that is running on some blockchain, and that can do any functionality that a bank can provide to you. That is like just exchanging money. It can do provide loans. It can provide interest on whatever money that you've deposited with them. It can the opportunities are endless. So anything that a bank does, DEX should be able to provide to you. But imagine now in Filecoin, what becomes great is that you already have FIL tokens with you that you've been getting for providing your storage to the Filecoin network, right? So you already have a collection of FIL tokens, and you're already contributing your storage. So why not use that? Why not leverage that and get other crypto loans? Because you're providing X amount of storage, you can borrow some Y amount of a different token on this lending platform. So that's basically what loans are. It's also possible to get under collateralized loans. So in any other DEX, so as I said, a blockchain network is decentralized to some degree, at least in the permissionless blockchains, it is completely decentralized. So the nodes that are there, they're just referred to by an address. You don't really know who they are, where they belong, which country they belong to, what is their social status, what is their security status. You don't know anything about them. So in what how do you actually give a loan to a person you don't know anything about, right? So you always, any DEX will always generally give you over collateralized loans. That is, you have to, for example, if I'm going to a bank to take a loan, I have to give something else to the bank in return as collateral, which can be a house, it can be some gold, or it can be anything. So similarly, in DEXs, you have to give a collateral, which is usually some other currency, and you have to, if you're taking X amount of X value of one currency to take X value of another currency as loan, you have to give more than X as collateral. That's how DEXs work. But since here you already have a kind of, a reputation system, because you've been a storage provider with Filecoin for such a long time, and based on your history of storage providing, and you can identify good behavior and even offer under collateralized loans. That is possible in Filecoin. It's a unique use case. And you can also borrow as you store. That is, you don't have to deposit another currency to swap. You can say that I will continue giving my storage facility for another 1 year for this amount of loan, to borrow this much amount. So these all of this can be automated in via smart contracts on the Filecoin system. You can have automatic repayments of loans. You can use multi-sig because of through smart contracts. You can even do yield farming and everything else based on your reputation score of yourself as a storage provider. So this is very interesting. So we can also do perpetual storage deals. That is, so generally in the Filecoin network, you offer your storage services for some cost, right? For you're basically taking rent for the amount of storage that you give. But nobody is going to just offer their storage for a very short time, like 1 week you can use my memory. That very rarely happens. So people are looking to rent out their system for a long time and continuously gain interest as a form of continuously get rent as a form of income. So now we can do perpetual storage deals, right? So that is, store once and leave it for a long term and let it earn its own rewards. So earlier, Filecoin was taking the responsibility. The users had to individually, provide storage and retrieve their storage and all of that. But now all of it can be automated. Filecoin takes the responsibility via smart contracts. So how would you do it? You can provision some wallet with a storage endowment, and you can set repair bots to monitor which files needs which storage. So Filecoin offers something that really cool called proof of storage, which basically means any file that you have on the IPFS network should have sufficiently large number of copies. There should be redundancy so that even if one storage provider crashes, the file is not lost. It's very important that the and the person who stored the data can retrieve it at any point, right? That gives us the availability. So every day, periodically, Filecoin provides something called proof of storage that basically says that the file that you have given to the Filecoin network is safe and sound, and sufficient number of copies are being maintained, and you can retrieve it at any time. So this FVM now can monitor this proof of storage, and if needed, it can perform replications. If, let's say, one person has withdrew their storage deal. So it has verifiable storage proof and ensures that data is being stored. So we have responsible data preservation. So NFT.storage is already on Filecoin. So NFT.storage is an NFT storage service which basically has the collection of all the NFTs. So now that is being stored securely on Filecoin via FVM. So another software, these are early builders of FVM, is the Lighthouse project, which also provides perpetual storage deals. Okay, next is data privacy. So data privacy and access control are also huge use cases that can now be built using a Filecoin virtual machine. So think of it. So you have a lot of data on the Filecoin network, right? So how do you retrieve and use these data in an access controlled, preserved manner? You can think of things like MPC or zero knowledge proofs that can securely handle and process this data. You can assign access controls to people who are accessing this data, and the contract can use information that is stored on the IPFS layer in a secure way without exposing any of the details. This is now possible, and there are two early builder projects like Medusa and Log who are doing this. This is also a good use case to explore. So now we have compute over data. So right now IPFS was giving us storage providers. Now Batra is a project that gives us computation providers. So you can literally let large scale decentralized compute run over the Filecoin network via projects like Batra. This helps us enable web applications. So if you want to run, like, let's say, a large data model or some training algorithm, you can use their service of computation provider. So it's like you can schedule some jobs maybe. Okay, so these are different data sets that are already stored. So Filecoin right now has 280 petabytes of data, and it's growing rapidly. This data is literally 9x of what it was last year. So since it's growing rapidly, Filecoin is here to bring that scalability on everything that can be built on top of this data. Data DAOs. So we're talking so much about data and data privacy, but some data sets, so all of these web applications will need clean data sets for it to run smoothly, for us to get better algorithms, better designs, better models. So we can kind of have data DAO. DAO is a decentralized autonomous organization, which is basically like a company that is run transparently over the blockchain. All the members of that company are on the blockchain. All transactions that the company does, all funds that the company has, everything is transparent on the blockchain. That is basically a DAO. But a data DAO is a DAO that is functioning with the sole purpose of maintaining a data set. Specialized members can come together and collectively curate useful data for a data set. They can govern on who accesses it, and who, even if somebody has paid access, they can control who buys the data set, who can use the data set, they can ensure that the data set is clean. And the treasury for maintaining this is also on the blockchain, and it's transparent. It's preserved by these members of the DApp. This enables very clean and sustainable growth, controlled growth. So there are already DAOs that make this possible. Called you have Data DAO and you have Lagrange DAO also that does this. So analytics industry is said to be a $346 billion industry by 2030. So it's very important for us to have good data sets and good mechanisms such as data DAOs to bring us to that level. And again, all of this can be automated. It's not a tedious process because of smart contracts. Right. Okay, so some of the web scale Web3 applications that are there. Okay. Yeah. So now, if you want to build on FVM, you are most welcome to do so. But if you are struggling with ideas, or if you just want general help, motivation, or if you're stuck, in some technical part, you can please take a photo of this image and scan this QR code and join the community. So you have builders over there who regularly clarify doubts with each other and have discussions. So if you're looking for an idea, or if you're already building something and need some help, you can check out this community. Right. These are some of the early builders of Filecoin. We looked at Lighthouse, Lurk, Medusa, Baclau, and other projects, right? So these are other different early builder projects. Again, you can also speak to these projects and get involved with them, learn what they're doing, and even contribute by joining the community. Okay, so now we spoke about what FVM is and what you can build on FVM. Now we'll talk more about how to build on FVM. So as I said, right now the Ethereum FEVM is already available on FVM. So it's time to take advantage of that. Anything that you've already been building with Ethereum can be deployed on Filecoin, because so this is important because Ethereum already has battle test. There are companies that have already built good softwares, battle tested softwares on Ethereum. They can directly port to Filecoin. So MetaMask can be used on Filecoin. We will shortly see how that works. You can also use Remix with Filecoin. I will show you how that works also. And you can even use hard hat with Filecoin. So Filecoin, so all of these slides I took from the Filecoin launch event that happened in Lisbon late last year. So all these files are also there on the Filecoin website, or I can also share them. I mean, anything works. So you can you can use all the libraries available to Ethereum, but there are some features that is specific to Filecoin that Ethereum doesn't know of, right? So Filecoin developers have built a library called filecoin.sol, which can interact with built-in actors and give specialized use. By actors, in Filecoin, you call smart contract actors. So you have specific, this library provides like Filecoin related data types and other utility and system features that are specific to Filecoin. There are, again, testnets are available on Filecoin. Wallaby is a testnet, but Wallaby gets frequently reset because that's where most of the building happens. The testnet that we will be using is called Hyperspace, which is just a more stable version of Wallaby. There are also block explorers like Glyph and FileMine, who are also Zondax, who are also early builders on the Filecoin network. So, yep. Okay, so let's, so again, this is the QR code for the community. You can take a pic, or you can just go to linktree/filecoin VM. Okay, so I'm going to stop here for a minute before we go into the hands-on session. If anybody has any doubts, or if you want to, if you have a question, please enter it in the chat box and I'll be happy to answer. Okay, so I'm going to share my screen again. Right, okay. Let me just. Okay. So let's just go to. So this is the Filecoin FVM website. So anything that you want to know about FVM more than what I just spoke about, please check this website out. You have the docs here. You can read about all the features and possibilities of building on Filecoin. Yep. Okay, so first of all, we're going to look at three things now. We're going to look at how to use MetaMask with Filecoin, FVM, how to use Remix, and how to use Hard Hat. So I won't assume that you guys already know how to use MetaMask. If everybody already knows how to use MetaMask, then we can save some time and skip this. Is there a way to find out? Okay, I'm not able to see the chat.
Yeah, I think we can just cover the basic
Okay,
of it.
let's cover it. No, not an issue. So okay, so I already have MetaMask over here, but I'm just going to uninstall it. So let's go to MetaMask and let's say remove. Okay, so MetaMask is gone from my system now. So let's go to metamask.io. Right? Okay. So here I'm going to install the Chrome browser plugin. So MetaMask, just to give you a brief about it, it is a wallet. It is a self-custody wallet. That means, as I explained earlier, your entry onto the blockchain, you can perform, transact on the blockchain with a wallet. That is basically your entry into that decentralized network. MetaMask is that wallet, and to access that account, you need a private key, and that private key is completely your responsibility to protect. That's why it's called a self-custody wallet. You have complete custody of your private key. If you lose that private key, you will not be able to do anything on that blockchain via that account, and everything that is linked to that account is completely lost. So let's create a MetaMask account. I'm going to add it to Chrome. Okay, so MetaMask has been added. So now we're creating a new wallet. You can if you already have one wallet, you can import one. But now I'm going to create a new wallet. I'm going to rush through here, but I highly advise you to read all this very carefully before you use the application. And it's always good to have one application for your dev, one MetaMask account for your dev, and one MetaMask account for your actual assets, because please learn from me. I have lost, I kind of uploaded my MetaMask private key on one of my GitHub repos, and all the funds were taken out from that wallet. So keep your assets separate when you're developing and when you're storing. So I'm going to create a very simple password over here. Please remember this password, right? Okay, create a new wallet. So please watch this video. I'm going to skip it for now. So the private key is generated from a set of 12 secret words. I'm going to show you the words because I'm not going to store any real assets, but you should keep this very, very safe. You should not show it to anybody, and you should not forget it yourself. So these are my 12 words. I'm going to copy these words onto a clipboard. Okay, so it's not getting copied. Let's just do it like this. So these 12 words in this order is very important, right? Okay. So now MetaMask is going to make sure that I remember these 12 words by asking me some questions. So does anybody remember what it was? Humble, zoo, and the third word was frequent. And then you have amazing, and then rail. Okay, so once I enter the words in the right order, I confirm, and my account is created. Awesome. Got it. Next, done. Okay, so now what I can do is I can click this jigsaw puzzle icon over here and pin this to my Chrome bar. So I can access MetaMask in this way. It's created an account 1 for me with this wallet address, which is the public key. And it automatically connects to the Ethereum mainnet, and I have 0 Ethereum. So now we need to point this MetaMask account to the Filecoin network. Okay, so I'm going to add a network over here, and I need to add it to the Filecoin network. So before I do that, I need to know how to access the Filecoin network. So I'm going to go to this website called chainlist.org. Chainlist maintains a very good repository of all the blockchains out there and all the RPC URLs to connect with each blockchain. So now we want to connect to Filecoin, and we want to connect to the testnet. Okay, so mainnet costs real money, so we're going to play with fake money, and we'll connect to the hyperspace testnet. So if you see, there are different hyperspace testnet RPC providers. Let's just choose any one over here. I'm going to connect wallet, and automatically my MetaMask is opened up, and it is asking me if I want to connect account 1 with this MetaMask. I'm going to say connect, and it's going to ask me if you want to connect to this network, which is the Filecoin hyperspace testnet with this RPC URL and this chain ID, and the native currency of that testnet is TFIL, which is the testnet fill token. I'm going to approve and switch. So now if I open MetaMask, it is now connected to the Filecoin hyperspace testnet with 0 TFIL. Awesome. So now it's time for us to do something with it, right? Now we've created an account and we have access into the Filecoin blockchain, which is powered by the FVM. So I'm going to use this popular tool called Ethereum, Remix, which is a very popular tool for IDE to code in Solidity for the Ethereum blockchain. So this is mainly for casual coding because it is not very dependable. You can't create large Solidity projects in this, and it is browser based. So for small projects, just for testing it out, for experimenting, it is amazing. Okay, so here you can create your own workspace, but in the interest of time, I'm going to choose a sample workspace template that already exists with Remix. I'm going to be showing you all how to create your own ERC20 on Remix. So let's do that. I'm going to choose this template ERC20 mintable. Let's make this mintable, and we'll create, let's name this token Ovia token. I'm going to say, okay, this is my workspace is now created, and automatically it's giving me some files, right? So for those who don't know, ERC20 is Ethereum request for comment, and this is the 20th request that was submitted. So it's called ERC20. But what this request does, it gives you a standardized a template and a function set with defined inputs and outputs to create fungible tokens. What is fungibility? fungibility is, I like explaining fungibility in this examples. You can easily just YouTube and learn what fungibility means. If you take a glass of water, if you take 2 glasses of water and say you want to pour 100 ml of water from one glass to another glass, after you pour in that 100 ml, can you differentiate in the second glass which 100 ml of water came from the first glass and what was the other water that was already there in the glass? You can't, right? Because they're very homogeneous. They mix with each other. That means you cannot differentiate two, let's say, molecules of water from each other. Similarly, you will not be able to differentiate two 500 rupee notes, for example, but you can, because the note has a number, but the value of the note remains the same. If I give you 500 rupees and you give me another 500 rupee notes, we both, at the end of the day, we have the same value of money. So that is called fungibility. There is no uniqueness between the tokens that differentiates them. They're all the same. So ERC20 gives you a fungible token standard that you can create any tokens on the Ethereum network. And now we're creating a fungible token for the Filecoin network. So I'm going to call my token. So this is a template. This contract is already available. Let's quickly go through this contract. It's written in this language called Solidity. And if you're familiar with the Ethereum ecosystem, you will know what Solidity is. So the first line is the license of the Solidity contract. The second line tells you the version number of the compiler you should use, Solidity compiler you should use to execute this contract. There are a couple of import statements. That OpenZeppelin is a very popular company that has created libraries for ERC20. So we are just importing 2 of the existing Solidity files. You can easily go to their open source GitHub repo to see what these files contain. So now the contract keyword specifies the start of that contract, and I'm going to call my contract Ovia token, which is ERC20, and it's ownable. That is, one person owns it. So again, I'm just changing the name to Ovia token here, and I'm going to give the symbol. So symbol is a acronym for the token for EC. For example, Bitcoin is referred to in all exchanges as BTC. Ethereum is referred to as ETH. And even if our MetaMask in Filecoin hyperspace testnet is TFIL. So here I'm going to give my own token ID, which is OVI. Okay, so let's save this. And a good practice when writing Solidity is to have one contract per file and to name that file the name of the contract. So let's change the name to Ovia token, right? So, okay, let's make it OV token. All right. Okay. So this is, I have given auto compile. So automatically this code is compiled, and you can see the green tick over here. So that means the ABI is already created. ABI and bytecode of the contract is already created. I'm not going to go into details of what ABI is. So let's just assume that it has been compiled into some form of bytecode, which can be understood by EVM and subsequently by the FVM. Because we know that FVM is running underneath the EVM. So let's deploy this into the machine, but we don't. So to deploy a transaction, we need any transaction on the Ethereum chain will take some amount of gas. Gas is kind of like the fee, or it can control how what the program does. For example, if somebody writes an infinite loop, right, and everybody in the blockchain is verifying that infinite loop, they're going to go into some kind of deadlock, or they're going to run out of processing power, right? Everyone's going to be stuck. So gas is a good way to estimate how much processing any transaction will take. So we need to, and that costs some money. So we need to get some money. Since it's testnet, Filecoin has given us faucets that will it has given us faucets that will give us free money to help us with our development. So let's just wait for this faucet to load. So faucet, it comes from the plumbing industry. It's basically a tap. You get free money when you open the tap, right? Taking some time to load. Meanwhile, I'm just going to copy this address. I'm not sure. Maybe the server is down. Don't think it is a problem with my internet. Okay, temporarily, I'm going to switch to a MetaMask account that already has some money. So let's do that. Okay, oh, I removed it and then it's loading. Damn it. Cancel. Okay, so let's see if it's still there. Okay, cool. So now you can see faucet here. Yeah. So let's open MetaMask, copy our wallet address, and I'm going to paste that address over here. And I have to verify if I'm a human or not. Containing a lighthouse, which is a lighthouse. This one. Okay, another page. As AI improves, these tasks also get a little bit harder. I think that's it. Got everything. Yeah, okay. So let's send. So this is the transaction address of, so once you send a transaction, so basically some money is coming from one contract to our wallet, and this transaction is recorded on on this address. So again, we're using the Glyph Explorer, Block Explorer. This is the CID. And it is still pending. So in Filecoin, in the Filecoin blockchain, block interval is every 30 seconds, and transactions are typically confirmed after 3 blocks. So every transaction is going to take us about 1.5 minutes. So we have to wait for that. So the value that they're sending is 250 fill, which is more than enough for our purpose right now. Okay, so let's come back to Remix here. Yeah, I think it's done. So let's see if we got, yeah. So we have 250 TFIL. Awesome. It's successful. So let's go back to Remix and we will deploy. So now we need to connect to our MetaMask account. So first I'm going to go to injected provider MetaMask, and automatically it's asking me if I want to connect account 1 with MetaMask. Yes, next, connect. It's connected. And if you can see, it is still 0 Ether, but I already have 250 TFIL. This is because Remix does not, you need to reload Remix every time there is a change. So let's reload it. This is why you should not use Remix for large projects. Let's come back to OV token. It is compiled. Now we're going to deploy it, and it's going to injected provider MetaMask again. And now you can see it's 250. And Remix automatically assumes it's Ether because it was built for Ethereum. So let's deploy it. Again, it's asking you to confirm. We confirmed it, and if you can see here, the creation of OV token contract is pending. So as I said, it's going to take us, so this is also a transaction that was deployed. It's going to take us around 1.5 minutes to confirm. And we can also see, yeah, let's speed this up. Okay. So this is a new contract. You can see the details of everything that we have done here. And so the gas fee that it took is 0.00003 TFL, which is okay. And you can see that once it's deployed, that much amount of people would have gotten reduced here. So let's just understand. So we after we deploying, we'll try to invoke this mint function. Mint function will basically create so many tokens, so much amount of tokens to an address that we provide. And it just invokes the underscore mint function, which is already there in the ERC20 contract that we've already included. Wonderful. I think this is done. If you want, you can look at the transaction. If you just click this, you will get all the details of this transaction hash. You copy it and go to the Glyph Explorer, paste it here. You will see all the details. Again, it's already success. But what we are going to do is, we're going to take, so Remix already shows the deployed contract addresses over here. This is the Ovia token deployed contract. You can see that this is the contract address that was generated. So we're copying that address and we have to import it into MetaMask to see. So what should have happened is we should have created the Ovia token, and it is owned by me. And if you can see that the gas was deducted over here. Let's try to interact with this contract. That is, we'll go to the mint function. Oh, okay, sorry. Address. Okay, so first copy the public address. I want to mint. So let's say here I want to mint, let's say 1,000 Ovia tokens to my address. So let's put 1,000. But Remix automatically assumes that this 1,000 amount is in the lowest denomination possible in Ethereum, which is Way. Way is 1 Ether is equal to 10 to the power of 18 Way. So we have to put 10 to the power of 18 over here. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So let's hit transact again and let the transaction take place. Again, it is going to cost us some gas fee. We're okay with that. So it's pending. So it's a pain to wait for so much time. That's just why scalability of blockchain is such a big problem, because you have very large confirmation times. So if you see the mint process is happening, let's try to speed it up. Okay, in the meantime, what we can do is we know the contract address. And so now we should check if 1,000 Ovia tokens has been minted to my address. That is the address that I just copied. So I'm going to copy this contract address, go to MetaMask, go to my assets, and I will import a token. So the native token is Deepen, which will automatically show up, but any other ERC20 you have to manually import it, because everybody's creating ERC20, so it is not possible for MetaMask to list out all the ERC20s available on the chain for every account. So let's import that. I'm going to paste the contract address of here, and notice that it automatically found out what the token symbol is, and also notice that it is 18 decimal. Let's add that token. So this transaction also got confirmed right now, and we can see that the balance, I got 1,000 Ovia tokens import. Awesome. So if anybody else is following me, is doing a code along with me, if you can share your address on the chat box, I'll be happy to send you some OV tokens. Okay, so we learned how to deploy. We learned how to integrate MetaMask. We learned how to create and deploy a contract on through Remix, and we also interacted with that contract. As a final, if we have some time, like another 5-10 minutes or so, I can show you how to use hard hat also. Is that fine, Bhavya? Do we have like 5-10 minutes?
Yeah, we sure.
Cool. So let's go to okay, just to kind of speed things up, you can go to this open repository called the Filecoin project, and it has an FEVM hard hat kit. So here you will find sample contracts that are already built out, and you can test them and you can like kind of replicate them and play around with them. So I will post this link on the chat. Can I do that? Or maybe after the talk, I'll post it because I can't see the chat window. Okay, I'm going to share it with Bhavya later and she will send it to you all. So in this project, if you can see, there is a contracts folder. When we wait for a transaction to happen, maybe we can discuss all this. So you can just clone this repo, just follow these instructions. And I have already done that. And I have so just going to open an editor of my choice, which is the Visual Studio Code. Okay. So if you see, this is the imported cloned GitHub repo, and this is a general structure of the of a hard hat project. You have a folder which has all the contracts. We'll be looking at the simple coin contract, which is the solidity file. You also have something called the deploy script. So hard hat is a better tool to build your smart contracts and deploy them on the blockchain. A deploy script is a script that you write to deploy your entire project on the blockchain at once. So you can write, for example, if you want to deploy the simple coin project, you can just invoke the deploy function here. And this is possible through the ethers.js library. All right. Okay. So here they've required the hard hat deploy ethers. So and also you have to make some configurations on what kind of network you are deploying to. So that is already available here. So we're using the hyperspace testnet with the chain ID 3141, and this is the RPC URL that we used to connect to that library. This is the URL that MetaMask is also connected to. And again, your presence on any blockchain is your wallet. So we already created a MetaMask account. We can simply add that private key over here so that when Hard Hat deploys, it's like you're giving permission to Hard Hat to deploy all your contracts. And we also have an additional helper script that will just give you some contract function specific. For example, in the simple contract, again, this is the license, this is the version number, they have some import. So in the contract, they've written some functions, tokens minted, there's a constructor, send coin, and receive. So for example, in the constructor, right, it uses this variable called tokens minted. So in your helper script, you specified that tokens to be minted variable should take a default value of 12,000 for the chain ID 3141. So again, you can experiment with it. But what I'm going to do is I'm going to use the MetaMask wallet that I've just created, and I need the private key of this wallet. So I'm going to click on these three dots over here and go to account details and export the private key. So now you need to type the MetaMask password that you entered while creating the account, confirm, and it will expose this private key to you. Again, this private key is basically constructed using an algorithm that uses those 12 words as input that we had to write and keep safely, right? Those 12 words were used as input, fed into an algorithm, and this private key was generated. By private key, public key pair was generated. So let's copy this private key and let's come back to our Visual Studio. And in the deploy script, I'm going to paste. I was just experimenting earlier. So I'm just, yeah. So I'm going to paste the private key that I just copied over here. Again, it is not a good copy to do this. I have done this before and paid a heavy price. So if you do experiment like this, keep it in your local system. If you are uploading it in GitHub, if you're pushing it into GitHub, make sure the good practice is to create a .env file with the git ignore, which actually has the private key. But just to make things a little clear, I'm going to write it directly here. Let's save this, and let's also go to the hard hat config file and also paste the key over here, save it, and what the error is. Okay. Got it. So let's try and deploy this. I'm going to do a yarn hard hat deploy. Okay, what happened? Maybe I changed something in this code. It's going to. Let's try and replace this file entirely. But I don't think I did. Yeah, let's try it now. One second, guys. Let's first. Yeah, so it's able to recognize the address. So it was able to. What is the problem? Okay. I don't know. It just started working suddenly. Okay, so now in the deploy script, I have commented out all the other contracts in this project. I'm just using the simple coin contract alone. We just want to deploy one contract. And as you can see, it is deploying. Okay, and it can automatically, we've already given the permission to use our MetaMask wallet with the existing TFL money. So yeah, so it's going ahead and using that money to deploy. That's why like the MetaMask didn't pop up, because it's a browser tool. We're not using the browser. And another interesting thing is we just pasted the private key here, but it was automatically able to get the corresponding Ethereum address. We can check if this address is valid. You can see 26CD, right? Let's see if it is the same address of our account 1. 26CD ends in 335A. So awesome. So after this contract is deployed, let's see if we can interact with the contract. Oh, awesome, it's done. So the simple coin is deployed to this address. It's deployed to this address. Let's see if that works. Yeah, so the contract has been deployed. You can see we just copied the, is everyone able to see? Maybe I should just increase this a little bit. So the simple coin contract was deployed onto this address. We just copied this address and we went to the block explorer, and yeah, we're able to see that the contract is deployed, but it doesn't have any transactions done to it yet. So let's try and interact with this contract. So we have a function. We have the, let's try and use this get balance function. So the constructor would have minted a default value of 1200 simple coin tokens to my account. So if we use balance, it should basically, and give the parameter of the address we want to get the balance of, this should return the balance. So a good thing about hard hat is we can write some tasks. So tasks are scripts that you can use to interact with deployed contracts. So they've already given a task for get balance. And if you see this, what this task does is it takes two parameters, the contract in which wherever the address of that simple coin contract, and the account, which is the parameter that anyway the function asks for. And it should return the value of balance value, right? So the way to invoke this task is, okay, so you have hard hat get balance, which is the name of the task, and you're passing in two parameters, which is the contract and the account. So the contract address is, oh shit, okay. Okay, let me just delete this because I won't be able to edit here. So I hope you can all see here. So this is the command for invoke to execute a task. So we need to put the contract address over here. So this is the contract address that we deploy to. So let's replace that. And then the account address. Account address is our MetaMask address. So I'm going to copy that and paste it over here. Oh, down. Let's just take the account from here. Ethereum addresses, this one, right? Copy. Yep. So now I'm going to paste this command over here. Sure. So again, so now it's returned the value 1200, which 12,000, sorry, which means that 12,000 amount of simple token is there in my wallet, and this we were able to successfully interact with that function of that simple coin contract. Thank you guys. I hope you understood. Please, I'm open for questions.